we're going to take a quick look at the common measures of center for a data set. So a measure of center is really just a value that gives us an idea of where's the middle of our data set. Now together these are called the averages. The first one that we're going to look at is the mean. This is the most common one that people think about, and it's the arithmetic mean. So for most people, when they hear the word average, they're actually probably just talking about the mean, where we add up all of our values and divide by how many values we have. Another one that we have is the median. This is the middle value based off of position. So when we arrange our data values in order from smallest to largest, it tells us who is in the middle. And the mode is another one. This is the value that occurs most frequently. Now we can have more than one mode, or in some situations we will have no mode at all. And then the fourth one that we're going to look at in this video is the mid-range. This is the value that would be halfway between the maximum and the minimum value. So now all four of these together are actually an average. So when in a mathematical sense, when we use the term average, it could be any of these that we are talking about. Okay, so not just the mean, which is what most people think average implies. Now, when we're dealing with different types of measures, we will sometimes use the term resistant. And if we have a measure that's resistant, that means the value of that particular measure is not influenced very much by any extreme values. So it resists influence from extreme values, also known as outliers. So we're going to take a quick look at how to calculate each of these measures of center. So first of all, to compute the mean for our data set here, we first need to add up all the values in our data set. So I'm just going to find the sum of all of these values. When I find that sum, I end up with 142. And then I need to divide by 11 in this case because there's 11 different numbers in my set here. So when I do that, I end up getting approximately 12.9. Okay, so my mean is approximately 12.9. Now there is a special kind of mean called the weighted mean. So this is going to be in situations where not every data value has an equal amount of influence or an equal weight. So oftentimes in courses, you might have your grades calculated based off of a weighted mean. So let's say that in a particular class, 60% of your grade comes from your exam scores, 20% comes from your homework scores, and 20% comes from your labs. So altogether, you have 100% because 60% plus 20% plus 20% is 100%. So that'll give us 100% of your grade. But now in order to do the computation, we have to consider these weights along with our scores in each of these categories. So it says that currently you have 20 out of 32 points on exams, 110 out of 115 on homework, 72 out of 75 on labs. What's your current overall percentage for the class? Well, what we need to do is we need to consider the weight. So the exams are 60%, so we're going to write that as our decimal. And our current score is 20 out of 32 on the exams. Okay, then I need to add into my next category, homework. Well, my homework is 20%, so I need to use the decimal equivalent of that. And I currently have 110 out of 115 points. And then I have 20% for my lab, so I need the decimal for that. And then I have 72 out of 75 for that portion. So when I multiply these first two together right here, I end up getting 0.375. When I multiply these next two together, I end up getting about 0.191. And when I multiply my last two together, I get about 0.192. So now I need to add these values together, and that's going to give me my weighted mean. So I add all those together, and I get approximately 0.758. So right now in the class, I need to change that to a decimal, I'm getting about a 75.8% for that class. Okay, so that's the general setup for a weighted mean. You have to take the weighted value times whatever you have in that particular category, and do that for each category, and then add your values together. Okay, the next value was the median. So in order to find the median, I first need to arrange my values in order from smallest to largest. Now, you don't have to write this out if you don't want to, but for most people it's easier for them to actually rewrite it out. So when I look at my data set over here, my lowest value is 9, then 11, I have 3 12s, so I need to make sure I list all 3 of those. I have 2 13s, then I have a 14, 2 15s, and a 16. Okay, it looks like I have all 11 of them here. Now, what I need to do is I just need to go and find the middle value in my data set. So I can mark them off as I go. I can just count in. However you want to find the middle of your data set is fine. So if I go ahead and mark them off, so I just marked off 3 from the bottom and 3 from the top. There's no reason I picked 3. You can do it one at a time. And as you can see, now I'm down to just having a 13. So in this case, my median is the value 13. So let's say we run into a situation where we have one more data value. So let's say I also have the number 7 in my set here. Okay, so when I mark these off, I now have 4 on the low end marked off and 1, 2, 3, 4 on the high end marked off. So if I keep marking 1 from the low end and 1 from the high end, well, you'll notice I get down to 2 values left. Well, if I mark both of these off, because if I do one on the low end, I have to do one on the high end, then I have no numbers left. So when I have an even number of data values in my set, I'm going to get down to where I have 2 numbers in the middle. Well, if that's the case, then we find the mean of these 2 numbers. So I would add them together. 12 plus 13 divided by 2 gives me a 12.5. So if that were the situation, then my median would be 12.5. So that's going to happen if you have an even number of data values in your data set. If you have an odd number of data values in your data set, it would be like what we had the first time where we just ended up with the 13. Okay, so with the median, make sure though that you always do them in numeric order. You can't just come over to your list and start crossing them off because you might not get to the right value. So in that case, we ended up with 12. Okay, our next one that we're going to look at is the mode. Well, the mode is just the value that occurs more often. And when we listed our data values before to find the median, you may have noticed that 12 was written down 3 times. It was written down more than any of the other ones. So 12 would be considered the mode. Now, even though there were 2 13s and there were 2 15s, because the 12 had 3 of them, that one is considered the only mode because it was the most that occurred. Now, let's say we removed one of the 12s. Well, then we would have 2 12s, 2 13s, and 2 15s here. In that case, we would have 3 modes. We would actually list them all. We would list it that our mode was 12, 13, and 15. If there were 2 13s, 2 12s, 2 9s, 2 15s, 2 11s, 2 14s, and 2 16s, so 2 of everything, then we would say there was no mode because there wasn't anything that had more than any other value in there. Okay, and the last one that we're going to look at how to calculate is the mid-range. So the mid-range is the number that is the middle, or that is right between our highest and our lowest value. So in this case, our lowest value is 9 and our highest value is 16. So essentially what we're going to do is we have to find the mean of those 2 numbers. We have to find the middle of those. So if I do 9 plus 16 and divide that by 2, I end up getting 12.5. So my mid-range would be 12.5 in this particular situation. Now there are